Okay, good morning, everyone. So, today we are going to start learning about natural language processing, right? So, the natural language processing is the backbone, like I would say, the backbone technology which initiates the chat GPT or whatever the chatbots that we are using right now, right? For example, if you go to our chatbot and ask certain questions, so most of the thing happens in the back end are NLP technologies, right? NLP processing. So after doing the NLP processing, then we get the GPT help to restructure the answer. For example, if I want to ask certain thing, okay. So this is the question you go and ask: what is meant by optimization? What is meant by optimization function to our chatbot? So what is going to happen? Basically, we know the machine cannot understand words, right? Even when we start processing, training certain voice to text, text to voice, and everything, we converted this word certain numbering form, right? Certain numbering form. So that is called embedding, right? Embedding. That is called embedding. For example, if I ask this question to the chatbot, what the chatbot do in the backend first it's tokenize this sentence, right? Or question. What's meant by tokenization? It will separate the word. What is meant by optimization function and the question mark. So it will separate each word and the symbols in the sentence. So that part is called as tokenization. Okay? What it does is it just break each word and take that each word and give a number to that word. 0, 1, 2, 3, 4, 5, 6. So we can see each word is given a number, right? So this is a token number, right? But there is an issue in this thing, right? So if I say what is meant by optimization function, and I add another sentence saying is optimization function good, something like that, right? I'll write this is optimization function good. Okay, so this is the thing. So now if you see here, so again there is one voice here, and optimization. I have another optimization here, and function. I have another function already here. There's a new word, but the question mark again. I have a question mark. So now the problem is how this word is going to be numbered. For example, if I want to number this thing, is I'll take is optimization again, function again, another word, and the question mark. So if I give the number, I'll give 7, 8, 9, 10, 11. So this is the 11th token. What going to happen is, so once I ask the question to the chatbot first is going to tokenize. So break each word, right? So now the problem is these words, if you see the optimization here, given different numbers, not the right way. because optimization is the same word. We can't give different numbers to that. So there should be a certain mechanism to give a certain numbering system or a certain way of representing a certain word in the algorithm, right? So that is called embedding, right? That is called embedding. So first, what is going to happen is when you ask this question to the chatbot is going to break this into pieces, each word. So that is called tokenization, right? After breaking out, we have an issue. If you give the token number, so same word have different token number. So further processing is going to get affected, right? So we have to make sure the same words in the same in the question should given the same numbering system. So that thing is called as embeddings, right? So when it's come to embeddings, there are multiple embeddings available in the libraries in the market and everything. So there are certain people use certain type of embedding function. So now I'm going to use embedding function. Okay, what? Right? What is a word? And I'm going to say this is the 0th position and the 1, 2, 3, 4. This is the four letter word, and this letter starts with a capital. So I'm going to give a numbering system like that. It's an embedding system. You can come up with your own embedding mechanism. I'm going to say, okay, this is a word. What is the position of the word? 0. How many letters are in the word? 4. And is the word start with the capital letter? 1. 0 means small letter. So it's a simple thing. So if I come over here, I go here. Okay, this is the first position. And 2 letter. Okay. And is it a capital letter? No. 0. So come over here, meant second position, 4 letters, no capital letter. Here by third position, 2 letters, no capital letter. Optimization, fourth position, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is the word number, no capital letter. So function 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So fifth position, 8, 0. So question mark is 6th position, 1 letter word, 0. So these are the embeddings according to Mark. So when I come to this one, again, what is going to happen is the embedding system that I create will go through and check whether the is there or not. Right? So the problem is this is small is. This is capital. So what is going to give this? Is going to give a same numbering system, but this is going to be 1. Right? 1, 2, 1. Optimization, it will go through again and find whether that word is given a word number or not. If it is given, it will give the same number over here. Or else, it will create a new embedding. Right? So when you create an embedding, so the embedding function will go by each word and give a number and go. Right? So when it's going to give a new number to a new word, it will go to the previous and check whether that word exists or not. Right? If it exists, it will give the same, or else it will give a new number. So similarly, when it comes to this, it's find out, okay, the same word is there, but the only problem, it's a capital number. Capital, start with capital letter is. So it's gave a 1 over here, but 1 and 2 are the same over here. Optimization, here also it's find the optimization. When it's checked back again before giving this embedding, it's found optimization is here, it's this one, right? Then it's given number here, right? Then function, it comes to a new word, new token, and it's go back and see, okay, is it a new word or a already existing word? We find out function is already existing word. So now it's go back and get this number and put the same number over here. And the question mark, it check, okay, is good. It good new token. Go back and check if the good word exists in the previous thing. Not exist, so it will give a new number. Right? So the numbering system will be, okay, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the good word will have 9th word 1, 2, 3, 4. 4 think and capital letter no. So this will be the embeddings for that, right? And for the question mark, if you go back and see whether the question marks exist in the previous words or anything, yes, exist. So it will go back and put the same 6, 1, 0 things. Now, earlier when we break it out into tokens, we couldn't find out it's just a token number, right? But now we have given an embeddings. So the same word, optimization. Here also the optimization, we have the same embeddings number, right? So now what is going to happen? So I asked the question. First, the chatbot tokenize the word, then give an embeddings to that system, right? So now we have an embeddings matrix, right? So that is the question which the chatbot understands, right? So now we have data, right? So this is the first week of lesson or fifth week of lesson, imagine. So you go there, select the fifth week. That means the fifth week database will be loaded. That database is my lecture note and the tutorial and everything that I have given. So in the database also, we have words, right? We have text and everything. So what it will do is, we need to use the same tokenizer and the embedding, the same one, right? To tokenize the whole PDF, right? To tokenize the whole PDF. So that means for each word, it will give a number, right? Here also, for certain words, it's given a number. This is one very basic example of embeddings, right? This is not the thing that we are using. If you use this one, chatbot will mess up, right? We are using advanced embedding mechanism. I will explain some of them. So now this is the token embedding vector we have. So we have a huge embedding vector for our database, right? Database. So what it will do is, it will try to find out this embeddings number in my database, right? So it goes through the vector. But when we do a face recognition system, what we have done, initially we take a face, fit into an embeddings or like certain vector format matrix. Then we have a database full of embeddings. So we go and check that embeddings and find out, okay, which this face matches with this embeddings much. Therefore, he is the person here. We allowed him into the room. So that's how we have done the base embedding. Same thing. So we ask the question, this is the embeddings that I have. Already I have used the same embedding function to embed all the words in that thing. Now we will going to go through the database, right? To match these embeddings with the embeddings in the PDF file. Then what is going to happen? It will find out the optimization function word in my PDF database, right? So then it's going to take that chunk. We call it as a chunk, okay? Wherever the optimization words find, it will take it out. It will take it out. Then this question plus the extracted chunks from the PDF, because we matches the tokens, embeddings, and we found out, okay, these might be the same answer for this. For example, the embeddings matching is there, optimization function, wherever in the PDF, it go through and find out. It will pick, okay, there is an optimization function, same embedding over here, pick it out, one. And go through here, there is an optimization function, same embeddings matches, pick it out. So you pick out all the optimization function word chunks wherever we have used and take this question along with the chunks that we have extracted and put it into the GPT. Yeah, ChatGPT, right? So the ChatGPT understands the question because it has the transformer architecture mechanism, right? So now we are going to the ChatGPT. So ChatGPT understands what is meant by optimization function. Is optimization good? It understands the words in a different tokenizing way. Then it goes through the answers that we have picked from the database using it, right? It knows which is the correct answer, right? Then it extracts the correct answer from that chunks and it reword it according to the question and give it to us. So that is the GPT part. So that is completely transformer architecture. We will learn about that in the next class. Okay. So what happens before it goes to the GPT? All natural NLP techniques. So tokenization is one of the NLP techniques. Providing embeddings is an NLP technique. And example, so there is a company reached out to us from Philippines, right? They want to monitor the social media of them, right? Including images, text, because they in Philippines they are happy, like in South Asia, right? We then in all over the world. So if you go to the restaurant, you don't like the food, take a photo and upload it to the Facebook. Worst food I ever had in my life. In this place, hashtag Pizza Hut or blah blah thing. So it's going to affect their sale actually. They are going to affect their sale. So what's going to happen is, if that kind of social media post coming to the market, it can go to the Reddit and start people will comment on Reddit, social media is going to go wider, their sales is going to go down. So what they want to find out is, okay, if a person posted in the social media about bad post or a good post about food related to my restaurant, I need to find out. And I need to reach to that person and say, sorry for what happened. So we will give a coupon of 1,000 rupees. So next 3 meals on us. So then the person will remove it, right? So making a deal is the thing. So they go to the guys from our side. So we will give 2,000 rupees coupon this issue. So if you could remove it from the social media post. Then they will say, okay, fine, we will remove it. Or else they will say, okay, negotiate. Okay, I don't, 2,000 is not enough. So 5,000, something. So they want to do that. So how many people are going to go to shop? For example, if you take Pizza Hut is all over there in Sri Lanka, like how many branches? More than 500, 600 branches, right? So in that case, monitor all these people. We can't, right? So what we need to do? We need to do a social media search. So there are APIs. That means if Facebook says we can pay and take that access, where we go and type out Pizza Hut, certain keywords, right? Pizza Hut, Sri Lanka, pizza. So those kind of keywords, what is going to happen is it's going to extract all the posts which were mentioning the Pizza Hut word or pizza or something in the social media, Facebook, and get all the text, images, and everything, and it will give it to you, right? So now what we need to do is we need to go through each and every post and identify whether it's a good post or a bad post, positive post or a negative post, right? Per day, how many people are going to buy pizza? Per day, how many people are going to post this in the social media? Maybe 1,000, 2,000 posts regarding pizza. So you can't sit and read all the stuff. So there should be a mechanism to identify that. So how we are going to do that? We are going to use natural language processing, right? We are going to go through each and every post, break down the text, and identify whether it's a positive post or negative post. If it's a negative post, we are going to give you the Pizza Hut one and say this is negative, right? So this is one example. Shakey's from Philippines reached out to us. We are going to work on that, and there are already built up model called social listening. Social listening is a whole technique, right? So you listen, you use this embeddings based stuff to identify and everything, natural language processing stuff. We are going to learn that thing today, sentiment analysis. Then finally, we are going to give it to them. But with the features of AI, it's become very easy. With features of GPT, it become very easy. Then ask whether it's good or bad. But only GPT is costly. For each token you're going to ask question from GPT, you have to pay. For that, we can stick to the natural language processing mechanism. We don't want to pay. It's zero. And zero cost. It's on your computer, your mechanism, you are going to run it and you are fine. But if you ask me whether it's effective or not, I don't. Because the way you can write can be different. So you can directly write, I have a pizza, in this Pizza Hut, it's disgusting, it's not worth for the money. Direct, bad, negative comment. There are certain ways, right? So you can say the negative comment in a positive, funny way, but it's negative for that. In that case, natural language processing will have a hard time to understand whether it's a negative or a positive comment. But the GPT will answer because it's a transformer-based architecture, right? Natural language processing, most of the techniques are neural network architecture. We call it as recurrent neural network architecture. Recurrent neural network architecture means it has a small memory feature. right? Small memory heat. For example, before this transformer architecture, ChatGPT, Gemini, everything comes up, we use for text processing. We also had chatbots before also, right? Before this 2017, there were chatbots. In think about its tree-based algorithm. What happens? You ask a question. These questions are predefined, right? So what a customer come and ask you. So what is the check-in date? What is the price of this? All these questions were gathered from the call center, and we narrate the answer manually and we keep it as a data. When you ask a question, it knows there's a question according to the same vector. It will go identify that same question and pick up the answer and display no GPT info. Right? If you ask a different question, optimization function means what? Sometimes it can miss the answer and say, I couldn't find the answer. Because it should have the same structure of the question the way you are. Now it's not the case. Because GPT is going to find the answer for you. What we do is we have to select the same words, chunks over there and put it into the dump it into the GPT. So that's the different techniques that we are using for the thing. So whatever the techniques now use upload a PDF and read it out from ask questions from the GPT, getting all these things, a natural language processing. Other important thing is identifying the key parameters, right? So for example, we have done a project for a company. You are using GPT, right? Now the GPT remembers my name. Hold on, let me ask, I will show you. I'm going to the GPT, right? Okay, I'm going to task thing. Okay, what is my name? See, it remembers my name now. Even I don't know this stuff. How these things knows about this stuff? Me, right? So you work extensively with audio signal and AI application, including projects using Google Colab, TensorFlow, various AI platforms such as Terramark AI. Crazy. Because I have used these Terramark AI, certain stuff to narrate certain words and ASCII PVT LTDs, your thing, BCS, test case generator. Crazy, right? So what are the things, what are the projects I am working on, which I communicate with the GPT? Everything it knows. So my whole database is there. Even if I forget, I can go back and ask what I have working yesterday. So it knows because it has the whole history. So imagine you are a security company, you can't have this kind of leakage. So you have to make sure GPT is not getting your information. So how you do that? How you do that? So there should be a way you find out certain sensitive information and you can hide it. So nowadays there's a problem, whatever the doubts come, you don't troubleshoot. Copy the trouble, copy the error, paste it into the GPT, ask, troubleshoot and give me the correct code. Around 95-90% of the time it's going to fix that. And you are going to copy and paste it and run it. You are a good employee. But the problem is you are leaking the sensitive information. For example, in the text that you have copied and pasted, there might be a passenger who is traveling from one place to one place. He is trying to book some flight. There's a credit card number embedded into that system. Right? Whole credit card detail is there. When you don't know it's the 2000 line something. So you copy and paste it, you get it troubleshooted, but what you have given to the GPT is the credit card number. Right? So then, if it get leaked, your credit card number is going to be used for the next training cycle of GPT 4.5. And if I ask, what is the credit card number of this person, it's going to can't do that. So how do you eliminate? Have a mechanism to identify certain sensitive information and you can hide it. Right? So what we have built up for this BCS is a the company where I do consultancy. So when they enter a query, we go through the whole, identify certain sensitive information using natural language processing, and we mask it with a different word. For example, I'm Dr. Logisan, want to follow, book a flight over here from this place, his credit card number is this thing, blah, 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 thing, it's that. Given to that GPT to reword it in a nice way, what will happen is Dr. Logisan will be masked with Dr. Michael something, right? It's identify my name, mask it with the fake name, right? It comes to the credit card number, it identifies that is a credit card number. Take my credit card out, put a different wrong number over there, and come there, my date of birth is there. It takes the date of birth, put a fake date of birth over here, and it's going to send it to the GPT. Now, so I take the query, I mask with fake information, I put it to the GPT. Then the GPT, what it gets is not my name, Michael something, not my credit card number, it's a fake credit card number, not my date of birth, it's a fake date of birth. It's going to draft the email or whatever, but with the fake information, right? So I get the fake information back to my GPT. Then I already know it, which I replace. Then I put that places where the correct informations are, and I display to the person who is using that GPT, BCS GPT. So what is this technique is called named entity recognition. Named entity. Another example that we have built using NER is identifying certain information for in that company. They are kind of a recruiting company. So let's say there is a person calling from US. I need 10 people in Node.js format who want to work in this project. Can you give 10 people? What they do? Immediately post their 10 Node.js people. These are the required thing on the LinkedIn. All these job posting they post, they get a CV, right? Because they have to recruit. So they get thousands of CVs for one job application. Now they have to sort out where these people who are matches for these exact suit, because I can apply thinking I have a small experience on certain thing they might take, but actually I'm not qualified for them. So then what they first do is they go through all the 1,000 CVs, find out certain information, list out in an Excel file, right? So there are 5 people working in that company to do that. So it takes 2 weeks. Going to go through manually copy paste or enter in the CSV file, email address, name, GPA, location, whatever the sensitive information that we are looking for a job, right? Then finally they sort it out. Okay, in the Excel file they go, okay, who have this experience, who has this thing, sort out and finally select and fill. So it takes close to 2 to 3 weeks to do that task. So we will have an algorithm using completely natural language processing. When they upload the CV, we have a name entity recognition, NER. It can identify the names, it can identify the email address, it can identify the EPA, all these damn things, and it picks up and put it on automatically. So it's just like you upload all the 1,000 CVs within 10 minutes, the work is done. Right? 3 weeks work, you can finish it within 10 minutes. Right? So I show those examples. So hold up, natural language processing. So natural language processing is there for a long time, right? After the transformer architecture, 2017, this GPT came up 2020, right? 2021. Then it's changed the way, right? So now natural language processing plus the GPT architecture transformer based things ruling the world. So right, even what is the GPT using the transformer architecture is certain techniques, embeddings, tokenizers that we language processing. It's a combination. So today we are going to learn about embeddings, tokenization first. Second, name entity recognition. We are going to build our own name entity recognition, a simple example. And the third one is sentiment analysis, right? For a movie review. So that is another important thing. Movies, if they get negative reviews, then they want to somehow pay and remove it, right? So they do it. Go to Google review, right? You go to a restaurant, if you stay in hours or maybe less than an hour, half an hour, finds out you were there. Right? Then it says, okay, we found out you were there. Can you give a review? So you find it's bad, then you post a review. Then the review will be appear in the Google review. When you search it for a business, it will appear. Right? In US, the Google review is one of the most before you go to a restaurant. That affects that thing. If you go to Indian restaurants in US, they have soup. What these people do is they have the access to delete. If you are a shop owner, you can go and delete that comment. Delete that review. So what they do is if you post a review, they is it bad, they manually identify it's bad, then they go and delete. Right? That's how the Indian stores have superb review in US. But one of my friends posted it, then a bad review about one Indian shop, buffet. The next day it got removed. Right? The owner removed. So that, but in US they don't do it. If it's a bad review, they try to compensate and make you remove it. Right? But Indians, who cares? They remove it by themselves. But certain reviews, TripAdvisor and Booking.com reviews, you can't remove. You can't remove. Those are solid. Right? So even Indian restaurants, they have bad reviews in the Booking.com and TripAdvisor because they cannot remove them. But Google, you have the freedom to remove because I can go and do anything. So there was an issue happening. There's a cafe, pepperoni cafe or something, right? Something bad to an employee, and the employee putting in the network, and oh, bad about that. So I have seen some comment. I went to this cafe, I found a brick in my food. So this is a funny comment, right? So to attack that thing, star rating, they came to 1 star within a day. Within a day, that can happen in Google. So then they apologized and they removed manually all these comments. Finally, they back to normal. So do you remember that event? 24 hours open? Huh?
Happened in Sri Lanka as well.
Yeah, I've seen Sri Lanka. What is it? Yeah, what is the shop called?
Happened to the hotel as well.
Oh, really? Okay. There's a cafe in Sri Lanka. So these are the effects. So if they have NLP techniques, immediately they should have done it, identify the negative comments and do that, right?
So people can do it purposely to make money.
No, they will identify. They will identify and they can report to the social media. This is a fake thing also. So there are techniques available. So if this is real, then they will try to compensate, give something, right? So like that. So these are the techniques available in the market that we are intensively using. Even the chatbot that we are using, even the GPT every day. Yeah. So that's what. So FB, we have an API key license. So we can subscribe for that license and where we can go and enter keywords. For example, Pizza Hut. So I want to search for the bad comments in Pizza Hut, Sri Lanka, maybe in Colombo, this branch, Bambalapitiya branch. I go Pizza Hut, Bambalapitiya, pizza, type the keywords, up to 5 to 10 keywords we can type. So based on the keyword, the Facebook will give all the posts which are matching with the keywords, right? So then you can identify all the post comments. Then if you have a natural language processing, you can send through that thing, identify whether that is a positive comment or negative comment. If it's a negative comment, you give it to the Pizza Hut. This guy posted a negative comment. You should take immediate action. Then they go read that comment out and they reach out to that person and they comment. So that is there. Many shops started to doing it. I'm not sure. Pizza Hut should do it. I think the worldwide they are rich, so they might be using it. They might be already using it. But it's not a big rocket science. It's a very simple mechanism that using the deep neural networks and the neural networks, right? So now we know the practical application where these things are used. Now we are going to go into the experimentation. Yeah. Yeah.
I search about you with the same thing on.
If you have the license, paid license, yes. Yeah. So there are APIs. So which is called as social listening. Yeah. So how Facebook make money? Do you think it's free of charge? You are using it for fun? No way. They earn money through these stuff, right? Social listening, marketing, everything they, right? For the API, for example, this thing, Silverchair, right? So I talked about a project where the business address and the business is uploaded. It will go through all the social media pages and find their rating, customer reviews, ranking, and everything. So we use the API. Keyword search, that's all. We type the keywords related to the business, break it into tokens, search it. That's all. Right? Then it's finding out and put all the thing over there. Simple. It's not a big deal. It's there. Social listening, it's a big thing. So there are multiple tools available. You can use it, subscribe and use it. But those are expensive. But what they do use, we are going to learn today. Right? If you spend some time, you can build your own thing. It's not a big rocket science anymore. Okay. The first is tokenization. As I said, tokenization means in a word paragraph or a sentence or whatever, we break the words into pieces. For example, tokenization is the process of creating tokens. We love NLP, exclamation mark. So we is a token, love is a token, NLP is a token, exclamation mark is a token. So these are tokens. So what is a token? Token can be brought as a building unit of text sequence, right? A string is constructed by piecing different characters together. Characters come together to build a word. Then many words come together to form a sentence. And a sentences from a paragraph form a paragraph, many paragraphs from a document, and so on, so on. It can go on. So each units that build up the text corpus are tokens, and the process of splitting the text sequence into its token is tokenization. So we have characters, words, part of words, punctuation, sentences, regular expressions, special token. So basically, if you take this one, this is a sentence. This is another big sentence. This is a sentence. This is another big sentence. Here you can see a sentence here. Is here, right? This here, right? These are two different sentences. If you want to tokenize it, based on the token number, this gives in the first token, this is the second token, sentence is the third, fourth, fifth, sixth. So this is the tokens, right? Token number. So you are going to use the token number as an embeddings number. You can do it. It's your algorithm, right? You can build up any embedding. Embedding means you give a number to a certain word, right? So I have built up a tokenizer. They have built up a tokenizer. So embedding mechanism where it uses the token number to form the sentence. So now if you take this is a sentence. This given a word 1, is 2, is 4, sentence is 5. 1, 2, 4, 5. 1, 2, 4, 5 is this sentence, right? Similarly, you go there. This is 1, is 2, another is 5, okay, 5. Big is 6, 6. Sentence 3, 3. 1, 2, 5, 6, 3 is the second sentence, right? So I differentiate using the tokenizer. But this is not only enough to build up a big document. So that's why we have to go for the embeddings mechanism. So what I explained over there is very basic. We never use this tokenizer in any of the real world applications because this cannot do the work. So we do embeddings for like size of 30 parameters. 30 parameters. For face, we extracted 128 parameters. For voice, we did 256 parameters. For a word, we do kind of 28, 30 parameters based on the tokenization mechanism that we are going to do, right? So you understand what is tokenization right now. Okay, let's go to the thing. So basically, why do we tokenize and everything we have explained. So what is time? These are the things. So then it's identify this is a question. Then after that, it gives the answer. So all the examples are there. Okay. So now we are going to use a NLTK toolkit. TK means toolkit, natural language toolkit, NLTK. Okay, NLP toolkit, right? So there, all the libraries are there in the Python. Most of the time, these libraries are intensively made for certain purposes. Those are well trained, right? It works most of the time more than 80% accuracy in certain cases. So when we build up the NER for the BCS, like ChatGPT, to mask the certain information, it worked around 75% accuracy to detect the names and sensitive information. But the problem is that our credit card number sequence are little different than the US credit card number sequences. They have 3344 detail or something in the US credit cards. We have 4444 numbers. So that NER is trained for detecting 3344. So when a 3344 number entered into that system, it identifies that's a credit card number, right? Because it's trained for that type of credit card number. When we enter 4444, it did not identify that as a credit card, right? So it's linked it to the GPT. So there are issues where we have to do the training again to make sure that pre-trained model suits our purpose, right? So that's also we are going to do in today's lectures. Okay, natural language toolkit. So let's first install the first tutorial. We have to install this thing. Okay. So first pip install NLTK, natural language toolkit. So there are many libraries available. You can use those stuff. So first I'm installing that to access that thing into the Google Colab. Once we install it, let it install. We are going to take import NLTK toolkit. Inside that, I'm going to download NLTK PUNKT. This is a tokenizer. This is a tokenizer function which is pre-trained to break the sentence into words, right? So we are going to use this library to tokenize. There are a lot of libraries to tokenize. You can use it. This is a famous library, PUNKT. After that, from NLTK tokenize, import word tokenize. So that's what we are going to do that task now. So we are going to import the libraries and download the required libraries to do the task, right? So after doing that, we will tokenize a word now. So we'll say, hello, how are you doing today? So I'm going to tokenize tokens, word tokenize, because that's the library I have imported here. Text, that's all. Print tokens. So once you print it out, you can see the output. Hello is broken up. Exclamation mark is taken as a token. How are you doing today? Question mark. All these pieces are breaking into individual things. So this is what known as tokenization. This is what known as tokenization, breaking a sentence into pieces. So we can change this one. Okay. Hello, welcome to AII tutorial number 11. Okay, let's see how it's breaken up. Hello, exclamation mark, welcome to AII tutorial number 11. So it's breaking up. So this is what called tokenization, right? We are using a pre-built library, word tokenized, which is PUNKT library, right? To do this task. So we don't want to train that. So tokenizers are well established. You don't want a separate tokenizer to build an application. You can use the existing tokenizer to do the tokenization because it's not a big thing breaking the sentence into each words, right? So now we have tokenized. So now let's say this is a long text, right? We are going to tokenize it. So long tokens, again the same thing, word tokenize, long text, that's all. Now I'm going to count how many tokens are there, right? So I'm going to print those tokens. So now if you see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, right? 42. But it says 49 tab. Why? Because I missed the commas, full stop, and these two brackets are counted as one token, right? 1, 2 tokens. So I missed that thing. So if you count all this stuff, we have natural language processing bracket, NLP bracket is a field of artificial intelligence that focuses on the interaction between computers and humans using natural language, and the full stop also taken as a token. So these are the tokenizers, tokens that we got. So this is a tokenizer job. So we can use this punct or word tokenize library to do that task, right? So now we will see, found out the words which are there existing. So find most common words in our text. So once I do it, so it's go through each as a tuple. This is like a tuple. So it goes through how many times the natural is there. So how many times the language is there, one by one. How many times the processing is there. In this list, finally, it come through this thing. So words count words and come out and print. Okay, there are 3 times the language word is used. There are of words 3 times used. Natural used 2 times. NLP used 2 times. Is used 2 times. So these are the time used. If you see natural, how many times? Language used 3 times. 1 time, right? 2 times, 3 times. Yeah, there are 3 times. It says of used 3 times. I'm going to highlight the of. 1F, 2F, 3F, right? So it's correctly counted. So it's just identifying the word counts using the same library over here. So now we know how to tokenize using this library. So it's a very simple. We are going to use an existing library. This is one of the library. There are many libraries available in Python. You can use that for free of charge. So after that, second thing is embeddings. Embeddings mean what? We are going to give a certain numbering format for each word in a sentence. That is called embeddings, right? So now I'm going to go there. Again, I'm going to use the punct thing. I already downloaded, so I disable this one. So all these things, libraries, the same libraries. This is the text, tokens, word, tokenize. First, I need to tokenize before I give this thing a thing, right? So now I tokenize. I'm going to number the tokens. So 0 to the total number of words. So now this natural language processing is fun and interesting. So it gave a token number 0. It gave a token number 1 for language. It gave a token number processing is fun and interesting. So this is one of way of giving an embedding. But do you think this is an effective embedding way? No. So the next sentence when it's come, okay, I'm going to say it like this. Processing is fun and interesting. Natural language processing. I'm going to get this one again and put it over here. Natural language processing is a great tool. Okay, just do it like that one. Maybe I need to break it down. Right. Okay. So now go there and see natural language processing is fun and interesting. Again, the natural same word, same capital letter, same everything. Now it's given a different number. So this is wrong. We can't do that, right? So we can't give this numbering system because it's just giving the number for the token. It's an embedding way, but it's not an effective way of doing the embedding. So let's move it into a little embedding system. Rather than relying on a token number, we are going to embed based on the token number, length of the token, and is the first letter capital. The same thing that I have do the embedding system. For that, I'm using a for loop for number of token in the number tokens because it can only do the embeddings for the tokens. First, we have to tokenize. After that, we are going to embed it. You get it? Yeah. So then the embeddings number, first length of the token, then one if token is 0, is super L0. So embeddings, that's the thing. So basically, we are going to get the token number, length of the token is the first letter capital. Then I'm going to do the embeddings for the same things. Let's see. Okay, now it's given as natural simple embeddings 871, language 980, processing 1010, is 1120, fun 430, something like that. First, let's break it out. Let's take it out, right? I'm going to take this out, right? I'm going to play this. So now you can see the numbering format. Here I'm going to play it. You can see natural is the first word, right? Natural is the first word. First word 0. 1, 2, 3, 4, 5, 6, 7. 7-letter word 7. And the first letter is capital 1. Language, first word, second, so there 0, 1. 1, 2, 3, 4, 5, 6, 7, 8. 8-number word, 8-letter word. First letter is capital no, 0. So like that, all the things I have added. So when I add the text over here, again the natural language processing, what is happening here is, this is, you can see, this is the 8th word, right? This natural. So what it does is, it first iteration, it go through it. And when the natural came again, it replaced with the second natural thing. So again, this is not correct, right? This is not the right way to do that, because it's go through each embeddings and find out, okay, the natural is there again. So this is the 8th word. Earlier it gave the 0, but now it's giving the 8th. If you put the another natural after that, it'll give that number to this thing. Again, this is not the right way to do the embedding. So now we will say how we can use the embeddings to find the similar words based on our symbol embedding. So now we are going to do that. Now you can see language difference 3 times, interesting word to processing, similar to processing, right? Processing is there. So if I want to say natural, so it will find out what are the things. Language difference, interesting. So those are the things. Similar to natural, right? So we can do that stars. So these embeddings, the way that we have done, we can also visualize that as a position vector. So like 2D visualization. Fun, it's a 3-letter word, right? Fun. If you go here, fun, sorry, 4th position, 3-letter word, 0, it's 0. So we can see fun is at 4th position, 3-letter word, this is a embeddings given. And if you go back here, and is a 5th word token and 3-letter word. Okay, take to the 5th token, 3-letter word, and. So we can visualize this in this tool manner also, right? That's a simple visualization thing. So when processing text to NLP tasks, it's common to assign the same embeddings to identical words. That is an important thing. Earlier what happened? It replaced the same thing with the second. If I put another natural, it will take that word thing into that thing. It's not the right way. So once we fixed first time, that should be the thing, should come to all natural, right? So now we are going to try to do that. So for example, the cat sat on a mat. The dog also sat on the mat. If you say sat on the mat, sat on the mat, and the are common, right? So what we are going to do is, we are going to do the same numbering system, token number, number of words, letters in the word, and whether it's capital or not. But this time, we are going back and check whether that word is existing in the list. If it is given, we are going to replace the same embeddings which is given for the first word. So that's what this code does using a for loop. This is our embedding system. Not in real time we are using it. It's the worst embedding system I came up with, right? To explain this thing. So now, when you do that thing, you can see the embeddings. The embedding is given as 0, 3, 1. If you go here, same embedding, 0, 3, 1. 0, 3, 1. The first embedding is given. When it's come back before giving an embedding to this system, it go back and check whether the same word existed and the token embedding was given to that word. Yes, it's given, so it's replaced. Then dog is a new embedding. So it gives the new embedding, the dog 8th. So the 7th token, 3-letter word, it's 0. Then also new thing, it gave a new embedding. Sat, there's a sat given. So now, according to the previous thing, it should give 930. But it is giving 230 because it went and looked back and get it back over here. Right? So again, we are getting certain embeddings like this. Now we can see the occurrence 2 times, 1 times, everything. So now based on numbering system. Similarly, we can create a plot. You can see most of the words are 3-letter words at different position, but there 2 times, but the same embedding, right? Cat 1 time, the same embedding. Sat 2 times, the same embedding. So that means same word is given a same number. We are good to go. So we are good to go. Cool. Now, this is a simple way of understanding these embeddings and the tokenization, right? But in the real world, we are not using this type of embedding. We use pre-built tokenizers, right? One is called as BERT, which is known as a very, very good in the field from 2013-12 time, right? So since then, BERT is a huge tool which is used to do these embeddings and tokenization and did all the natural language processing based stuff in AI until the GPT comes up. So BERT not only give a token for a word, not only on the position of the word, right? It can also understand the context of that thing, right? For example, the same word can be used in a sentence in different places, but the meaning might be completely different, right? The meaning and the emotion it carries may be completely different, right? So if you take a word, like I don't know whether I can say badass, right? Right? It's a bad word. But in US, if you tell it, he's an excellent guy on that, right? That means he's badass on this technique, mean he's super good on that thing. So it's a different context. Same word, same thing, but used in a different scenario. Meaning is completely different. So that is very important when you are trying to work with the natural language thing. So BERT is trained to identify the word location one thing and identify the meaning of the word, and it will give an embedding for that thing, right? So that's how the BERT is trained. Not only the position, not only the number. This is the worst embedding system I just came up with to explain you. So the BERT is a different. So we import the BERT tokenizer, BERT model. So what the BERT is going to do is the same thing. First, it's going to tokenize it. After that, it's going to give a embeddings for that thing. So let's play this one. This is the text I'm going to do. BERT is a powerful language model for NLP tasks. BERT is also really good for NLP. So there is an NLP. There is an NLP. This is a small NLP. There is a capital NLP. There is a BERT. There is a BERT. These two BERTs are totally different way it was mentioned. Now I'm going to play that thing. Right? It takes a little bit time because you can see the tokens are huge. That means it's not a 3 token vector, right? It's going to be larger than the star. So here you can go here. You can see this is not one. This is not one at all. This is not one at all. First, what it done, I put it as a capital word over here, BERT, right? What this BERT has done, it's completely make it into all small letters. The first BERT become small. And the other BERT is also becoming too small. So that means we only care about the word, whether not capital or not, we don't care. Totally fine. So now go and see the first BERT is 0.3417. The second BERT 0.3923. Not the same, not the same. Minus 0.2206 is the second embedding. Minus 1624, 0.1624. Third embedding 0.2097. Third embedding 0.549. So how this embedding works? How this embedding works? You can just type in Google and you can go through this document and identify how these tokenizer functions, right? What are these embeddings means, right? This is the BERT community. So now it's a huge embedding model, right? So it gets an array of this much, 16768. You can see this many numbers are given. And it consider not only the word length, not only the word location, it consider the tone of that word, where it have been used, what is the sense. So for example, here, BERT is a powerful language. BERT is also really good for NLP. So these two are BERT, but different location. It carries a different sentiment. I don't know how they have built up this BERT to break the sentences, but it's a available powerful tool we can use for industrial application. It's a very promising. For our chatbot, we use the LangChain tokenizer. So it's a library provided by LangChain, right? But we can also use the BERT. So all the chatbots, if you take it out, all are BERT. Even now for this chatbot, you can use the BERT. What it do? It break down this thing, give the BERT the thing. So now, not only this, each alphabet on the dictionary have an embedding, right? So the BERT knows the same embedding words, but it also analyzed the sentiments, where it have been used, everything, and it gave a word. So when you search how many times these words occurs, it will go and check the embeddings and find out, okay, this word matches with this word 70%, 80%, the way we matches the face with the embedding. 70% match, 80% match. They put a threshold. If a word matches 80%, 87%, then it's the same word. That's how they identify it in the BERT. So BERT is a tokenizer and an embedding system where we can give a certain number. So the full embedding, if you see how large it is for one word, you can see it's a huge embedding, right? So because it's carry a lot of stuff into motion, embeddings, name, blah, blah, blah thing. I don't know. There are a lot of stuffs over here. Okay. So let me explain why two instances of BERT have different embeddings. Yeah, it is explained over here what I have told right now. You can go through that. So now we will take the both BERT and compare. You can see there is a significant difference. But if you take another word, for example, let me take what are the other things? Powerful. There is a difference, but here we can see this is plus plus, this is minus minus, plus 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 minus minus. At least kind of same thing. Let's put the powerful here. Minus plus, minus minus, plus plus, plus plus, minus minus. But there's a difference. This is minus plus, right? So it actually go through the embeddings and it try to find out which has the maximum, right? So now we'll go back to the BERT. So you will see the BERT embeddings are similar because they represent the same word, but not identical because of different context where it have been used. This contextual nature of BERT's embedding is one of the strengths of this BERT embedding system, where it have been used also added into this embedding system. So now are you clear with the tokenization and embedding, right? So first, when you ask a question to the ChatGPT, what it happens, we break it into this thing using the BERT. One more thing, I can't use BERT for this breaking down, and I can't use a different tokenizer and embedding system for my vector database. You cannot get the answer at all, because this is going to use a different mechanism to tokenize and embed it. And in the database PDF file, my lecture notes, I can't use a different one. Both should be the same embeddings. If I'm using an embedding system for this one, the same embedding system should be used for that one. Then only the words will match. This have maybe 256 embeddings for one word, where I use 300 embeddings for my vector database. Completely wrong. You can't identify the correct answer. So whatever the things you use, it should be consistent. If you use BERT for this, for that embeddings also you should BERT for that. Clear? Good. So now we have understood the NLP, tokenizing and embeddings. So these are very basics. Now we will go back to our tutorial, go to the course, and finally second NER. We'll open it up. Named entity recognition. Named entity recognition. Let me save it. So tokenizing is done. So now we are going to come to the named entity recognition. So before going into the named entity recognition, I will show you one example here that we have built up HR. So in a series, we build up, identify the names, email address, mobile number, and everything using NER. Then we extract all the information and put it in an Excel file within a short format of time, short period of time. If anyone needed this tool, please let me know. You can subscribe for it. So it's our design, right? So it can hire people with free of charges. Even we can build me in Indeed and big. Okay. We were discussing about the NER, named entity recognition. So let me go to that part. So named entity recognition, you can see. So Andrew Yankan, Chinese born, blah, blah, blah thing. And you can see it's identify the person name. It's identify the nope, date, nope, American. These are NORP category. I don't know what is that. Organization or country or GPE. This is organization, Beidou, Google Brain organization, artificial intelligence group is identified as Google thing, several thousand cardinal. So these are entity names given, right? So we are going to build a named entity recognition stuff today. So for let's first use the existing library, right? So first we will install the Spacy model. Spacy is the pre-built trained named entity recognition model, which is available in Python. So you can directly download. So the Spacy model, SPACNER category catalog. If you go there, entity recognition Spacy API documentation, you can find out what are the categories it's trained for. Right? We can say model is okay. Let me check. You can go to the Spacy library. You can find out there are three species, right? One is large, one is small, one is medium. So SM means small, LG mean large, M mean medium. So we are going to use today the large one, LG, right? So we are going to use the LG mean. It trained for multiple names, right? Can recognize organization, names, Gmail, email, number, credit card, whatever the things you name it, it will be able to do that. Okay. So now I have installed. After that, I'm going to import the Spacy library. The language that I'm going to use is Encore Web Large. If is it large, large. If I want to use small, SM, right? So I have installed the large thing. So I'm going to use the large thing over here, right? Import Spacy, NLP, loading. So I'm going to define a document, say Manchester United Football Club is a professional football club based on Manchester. English established this in 1978. So I'm going to create a doc. So this is the doc. And I'm going to entities in the docs, right? What are the entities detected in the doc using my language model? So Spacy model. If you see, Manchester is detected as a GPE. I don't know what is GPE. Let's say, let's cast GPE in spacing. What is GPE? GPE is country, city, states. So they say country, city, states, if is it detected, it belongs to GPE category. So you can see Manchester is a place, so it detected and it put the GP, right? England is a country or place, right? So GP, right? 1978, it's detected as date because we have trained the spacing model as date. Manchester United Football Club is detected as organization, right? So only thing that we call this spacey thing, NLP. So I say for EN documents, print ENT text, ENT label. That's all, right? So it's identify the stuff over here. Maybe I can change it out a little bit. AII is a AI teaching platform which is designed by ASC DSP and XCDF. The owner is Mr. Para. Let's say something like that. All right. Okay. Now I'm going to run it. AII. Now the thing is LOC. It's not detected as GRE. Why? What is LOC? LOC, non-GPE locations. That means all the location in the world are trained as location for spacing. AI is detected as non-GPE location, maybe mountain ranges, bodies of water. But AI is an organization. It should be detected as an organization. But it detected as LOC. And para, person, it's fine. Right? Person, it's detected. For example, we will add something. I'm going to ask GPT to give me a thing. What the hell? Okay, anyway. So then I can ask Gemini too, right? Expand the sentence by adding names, org, c for any example. Okay. Okay, I'm going to see. Okay, we'll see. I'll copy paste here in this place. Okay, and play it. Okay, going to detect what are the things over here. So now you can see AI detected as a product. It's not a product. Dubai GP location, fine. Para person, AI organization. See, first AI is detected as product. Second time when it's come, it's detected as organization. AI is as a something LOC. AI again the product. So the space is not a well-trained model for unknown entities. For example, I am a company, I am working on AI, I need to protect certain information, but the spacey cannot detect me. We are going to leak the information. It's not good. So then we need a custom model to do that, right? Okay. So we can use, let's say we are going to go to a newspaper website and we are going to see what are the important information found out from that newspaper. using spaCy model. To access the newspaper, I need to just install this pip install newspaper 3K. After running that, so this is the link of the newspaper that I'm going to go there. Go here and check it out. What is it about? iOS 14 is now available to download. See, this is the article. So I'm going to find out what are the named entity models that this NER can figure out the spaCy model based on the pre-trained features. So now we are going to go there, go and download. It's detected Apple as an organization. What is this 0 to 5? 0, 1, 2, 3, 4, 5. So right up to 0 starting point, 5 is the ending point, the word. So if you go to this thing, this iOS news, it starts with Apple, right? So from this point to this point is detected as an organization, right? Again, cardinal, right? 14, cardinal, right? 14 means here somewhere around 14. iOS 14 is there. The 14 is detected as cardinal category. 6S detected as cardinal. SC is a product. Again, somewhere it will come as an Apple, let's see, Apple Maps, Notes product. So these are the things it got detected. Today it's detected as date. So this is the word starting point, letter starting point and end for this today in the text. So iOS 14, it's date. It's detected as date. See, it's wrong. iOS 14 is not a date, right? It's a something else. So this NER is not suitable for everything. So you can't use it. It's a large NER. So what we have done for the BCS GPT, we tried to use spaCy. spaCy didn't work because it's not trained for our application. We use certain information of airlines, certain numbers of airlines. Those are not recognized by GPT. So what we have done, we trained our model on the custom data. So how to do that? We are going to see it right now. So we can check, okay, these are the information over here. We can also mark it as it is. For example, I'll go and pick it up this one, the pasting option here in the text. I'll just go here, paste my text over there and identify what are the key information. These are visualization ways, basically. Okay. So you can see AII is missed. AI product, AI is detected as product. Dubai is detected as GPE. AII as an organization. AII as LOC. This is wrong. Basically wrong. Right? But it's somewhat detecting based on the pre-trained features. The spaCy model. So we can also detect, do that thing in a little different way. How these words are correlated. Right? So this is a linguistic way, the approach of these linguistic persons think. So this will give an idea to them how the words are correlated or something. I have no clue why this graph, how the graph is read, right? So this is, let's see how our AI thing, see that thing. Okay, you can see AII. So if you go down back here, there is an AII platform, noun. So leading. So how this listing breaking down is happening is explained over here. Okay. Now we are going to train. We have seen the inabilities of AII, right? So this spaCy model to detect certain information which are really sensitive, but it didn't detect. So I'm going to train my own thing. So pip, I'm going to install the spaCy. What I'm going to do is I'm going to load the spaCy model and fine tune it or do a transfer learning training approach to train the model. spaCy model is there. We are going to train certain layers of the spaCy to do the NER task. So I'm installing the spaCy required library. After installing, I'm going to take the small model because I'm going to detect only two in this example. One is a brand, other one is a product. Brand and product. I'm going to only use this NER model to detect the brand and the product. For that, that small is enough. Large is little larger for me to take and do that thing. So now I'm going to load the smaller model over here for the training. So now we need to create the data set for the training. So the data set is created like this. You can see a product, brand. So these are the labels that I'm targeting to detect from the text. So Apple released the new iPhone 12. So this is the sentence. So in the entities like this, I need to create a data set like this. Okay. 0 to 5. 1, 2, 3, 4, 5. 5-letter words. Starting sentence is 0. So 0 to 5, I have Apple. That word belongs to a brand. Right? Then I come over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Right? 25. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 22, 1, 2, 3, 4, 5, 6. Okay, 22, 21, 22, 23, 24, 25, 26, 27, 28, 29. iPhone 12. iPhone 12 is a product. Is it clear how I am defining? I put a sample example sentence. In this sentence, from this point to this point, it's a brand. This point to this point is a product. So it's on my custom data set, right? Nike is a Air Jordan shoes are popular. So this is Nike is a brand and this is a product. This is a brand, this is a product. Here I have created a certain number of examples. If you ask me, it is only enough, it is not enough, right? We have to have hundreds of examples. It's a tedious task to do, right? So I can say NER label. NER label, text name data labeling template. So you can go here, you can use this label studio docs. You can label it like this and you can download this as a JSON file. This will be downloaded as a JSON file. So you upload a text into that chunk of text, you select that certain named entities and say this is belongs to organization, this is belongs to doing that. So then finally all these things will be noted out. Finally, you can download it as a Excel file over the JSON file for the data. So here I don't do that. I just created my data set like this. Coca-Cola is a new beverage spread. Okay, entities 0 to 9 brand, 31 to 37 product. Simple. This is the data set. You got it how I am doing. This is only two things, product and a brand. So if you want to do the training for multiple tasks, you have to do that in a certain way. So I created the data set for the training now. So once we come to the training, what is else remaining? We have to split the data for the training and testing. So I need to run for 100 iterations and I'm creating the optimization function in these things and I'm going to do the training. It's a very simple trainer for that thing. So now the training is happened. You can see the data is split. So I'm using an optimization function and you can see the losses are not going in a very nice optimization way, but it's coming down. You can see the losses are coming down. Each step, each iteration, the losses are coming down. It's faster because I have very less number of data. So you have to have a lot of number of data to do the training. Okay. So the final loss I got is this one, right? So I'm going to test the model now, train model. So the text I'm going to put is I bought a new MacBook Pro from Apple yesterday. So this is the sentence I want to check. So I load the train model and I just checked it now. MacBook 15 to 22. The place here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. This is MacBook, right? The MacBook 15 to 22 is detected as a brand. Pro 22 to 23 is detected as a product. That is wrong. That is actually wrong because MacBook Pro is the product, right? But it's MacBook as a brand, Pro as a product because the training data is not enough, right? So then Apple is detected as a brand. This is the place the Apple is placed, and it saved the model, and this is the thing. So let's load the model and test on some other brands like Amazon, blah, blah, blah thing. And see, we'll see Amazon as a brand, Kindle as a brand, Paperwhite as a product, Microsoft as a brand, Surface as a brand. And these are the tokens and their entity labels, right? So these are the things. Let me go back and check, get this AII part over here and place it and see what our trained model is detecting on this AII text, right? So it's not a big deal. We can train, but the only thing is the data. So what we have done, we have created kind of 2000, 3000 data using that named entity model. Then we have trained the thing for the BCS GPT, which we are sensitive in. So here, AI is detected as brand, AI is detected as brand, XC is detected as brand, DXP is detected as product because it's not well trained, right? So when you want to design a custom named entity recognition for your organization, you have to make sure most of the brands that you are working in, most of the products that you are working in, all should be there in the exam. Then you train, then you do it. So I was loading this page earlier to show the named entity recognition. So let me go to that Streamlit and app. This is the CV app. So here I go CV matching and scoring. So this is the thing. So I can select the feature. So this is a natural language processing mechanism. It go through the sector and it identify these things as key skills and everything from the job specification. And you drag and load. This is the job posting. Look, I'm looking for this job position. And you select the feature. After that, you load all the CVs over here and load the resumes. And you can select the model for this thing and you can score it up. So it will take a couple of seconds to or minutes to score it up. It go through the CV, identify whether keys, find out certain key information, select those named entities into a certain spot and match that named entity tokens embeddings with the embeddings of this job specification, right? And identify how much match the job specification suits with the CV experience. You get it, right? We are searching through the embeddings, right? So now it will select all these things. There are 7 test CVs I have rated out. Among that thing, Charit Veerasi is the highest scorer. So you can see all the named entities I have found out. I found out the name, put it in the name. I found out the candidate name, put it over here. Overall score, this is the score that I used to score using NLP and GPT. It scored earlier in the previous. And age, it's found out. GPA, it's found out. These are the contact details, it's found out. How it found out? Because the NER that I am using knows about these details. And there is an NER for CV. So you can type it out. NER for CVs. OCR and Ocean NER. So these tools already there. NER annotated CVs. You can download this model and use it. Right? So I'm using these kind of models in the backend for that purpose. So that is NER. You can now build up your named entity recognition without any issues, right? So we know tokenizer, we know embeddings, how it happened in the vector store and how we find out the same words by matching. Now we know how the NER works, right? Named entity recognition. So the third tutorial I would like to go is okay, I need to go to the 11th and come back to this 3 sentiment analysis. That is the other natural language processing way that we are going to do. These are very common use things. So here, as I said, positive or negative, we are going to do over here. So whatever I have explained, everything is here. So you can go through that. Positive, neutral, negative. So we are going to detect, mostly it's used in social things. Again, we are going to use an NLTK, Natural Language Toolkit. Let's install that one first. So the explanation I'm not going through again because I have explained where it have been used and everything. Go through that. So we'll directly jump into the tutorial. So we will install whatever the requirement over here in the NLTK. So because we are going to build up a movie review, right? Detection mechanism. The movie after the movies, they want to, because you can't go through one by one. So they release a movie. The producer want to know what about the negative and positive comments? How many people commented positively? How many people commented negatively? I want to know that. Then what is going to happen? You can't go through millions of reviews. You just apply this thing, find out this is a good review, bad review, count the numbers, which is good, which is bad, done. So out of that, IMDb rating is given, right? So the rating for the movies are given using these features as well, right? Based on the comments. Okay, now we have used the NLTK as earlier. Then we are going to come and put this thing, import all these libraries. Here I'm downloading all these libraries. We are familiar with most of them. And one thing I am downloading is stop words. Okay. I'm going to tell two things, two sentences. Let me know whether they are bad or good, right? Review about a movie. Watching this movie is time wasting. Movie is bad, right? So this is one sentence, right? I'm going to type it out. Then let me take it and type it out here. Watching this movie is time wasting. The movie is bad. Okay. Right? This is one sentence. Second sentence, I'm going to type watching movie time wasting. Movie bad. What I have done, I remove the this from the watching this movie. I remove the this. I remove the is. The movie is bad. I remove the and is from the second sentence. I typed it back. Watching movie, time wasting, movie bad. So the first sentence says watching this movie is time wasting. The movie is bad. Directly negative comment. Again, watching movie, time wasting, movie bad. From this thing, if a person is giving these are the keywords, what do you think? You can identify the movie is bad. Wasting comment. Actually, this is the of, for, are not having any meaning for sentiment analysis. So no point of taking that words into this action to the training. So we need only the words, keywords, right? Then based on the keywords, bad is there, time wasting is there, definitely the bad review, right? So that is called remove the stop words. What is going to happen? Let's say whether watching movie, time wasting, movie bad. Stop word removal means what we are going to use is we are going to remove the this is for of that kind of connecting words and then everything and only going to get the keywords. So that is going to go for the review training. These words comes in, these are bad review. These words come in, these are good. So that is why we need this stop words thing over here. So I'm going to download certain data sets. Let me see. Yeah, okay. Let me download this one. So the same thing, we need to upload our Kaggle file here. Last time we are going to go to the Kaggle. Let me go to Kaggle. I'm going to upload the Kaggle. It's asking for that. So go Kaggle download, open, then it will automatically upload the Kaggle over here. Then you can download the JSON file, which is available for the movie sentiment IMDb data sets, right? So it's download and it's unzip also. This we have done in the past. So IMDb data set, 50K movie reviews, 50,000 reviews. They have labeled it as whether those are good or bad. So now we are going to use these reviews for training our thing, and we are going to detect in the future whatever the things, you know, the IMDb rating, how it's given based on these reviews of the movie, of the people. So it's a natural language processing task, right? We go before going watching a movie in the Netflix, we go check the IMDb rating. If is it good rating, 7.5, more than 6.5, we go watch a movie. If is it 3, 4, then we never watch the movie. It's like me. I before go, I watch the movie reviews first. Otherwise, waste of time, right? But it can be also manipulated. How come? Because I hire a team, enter good comments. They go and pile up with good comments, come up with this thing. That happens for Tamil movies. You go a Vijay superstar movie, any movie release, their fans go and comment about really good movie, good movie, good movie, Kerala. Good reviews are posted, but it's a bullshit movie, right? When you go to IMDb rating 8, how amazing movie Kerala you go and watch, it's a bullshit movie because IMDb review is manipulated by the fans of that guy. And it's also paid services are there now. In China, if you want a movie to hit maximum views in your YouTube channel, you go and hire that guy. They have millions of computers, IP addresses, mobile phone connects over here. They play that video in all these devices. Right? Now is a task. In India, Tamil Nadu, there is a culture. Vijay or Rajani or Ajit's movie releases. Within 1 hour, who reaches the maximum target views of that trailer? It's a competition now among the fans. So when the releasing time, they are ready to watch in multiple devices. It's a manipulation again because what AI think based on the review. So if you are watching a Tamil movie, IMDb rating is not going to work over there because our people fooled the AI NLP system using that thing, right? I have got affected by this thing because I have couple of times I watched a movie based on the reviews, but it didn't work. So these are the data sets. One of the other reviews has mentioned that after watching just one episode, you'll be hooked the positive comments. A wonderful title, little production, positive, 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 negative. The cast played Shakespeare, blah, blah thing. Appreciate that he's trying something negative. So they have thousands of reviews, like that 50,000 reviews. We are going to use that review for our training data set. We have downloaded it. You can see IMDb data set, IMDb data set, CSV. We are done. So after that, what we are going to do is we are going to open that thing and we are going to see whether the data set, how it looks like. So we have 25,000 positive, 25,000 negative. Because while we are training, we should make sure we are training with the equal sample size or more or less equal sample size. Otherwise, the model will think implicit bias. Let's say you have 40,000 positive and 10,000 negative. The model cannot identify the negative. It will say whatever the negative comment as positive because your training data is biased, right? So it's not happened. So they have selected 25,000 and 25,000. So this is the frequency of the review length. So there are around close to 1,000 words. Maximum reviews are around 1,000 words frequency, right? So like that, this is a histogram. So now what I'm going to do, I have all these words. Wonderful little production. I thought this was a wonderful way to spend, right? I need to remove the stop words over here, right? I'm going to remove the stop words over here. So I'm removing using this library and I'm reading this file from there, 15 movies CSV, and I'm removing the file from 50,000 reviews. I'm removing there is are all these meaningless words and getting the thing because that is enough for me to put the review. Otherwise, I'm going to unnecessarily confuse the thing. Here you can see tokens are used to tokenize each word and remove the there are is unnecessary words. First, we tokenize the whole review, remove the unnecessary word, save it down. Second review, tokenize it, remove the unnecessary word, save it. Like that, I'm doing the task. It's going to take a little while because it need to go through all the 50,000 reviews, right? And it's going to take it out. So that's the data I'm going to use for my training. Similarly, you can also build up review about the Pizza Hut to train whether it's a good review or a bad review, right? This is for a movie. So that's how these things are done. So those are not rocket science. Whenever anyone do it, can you do it? We can do it, but knowing what is happening in the back end is the key over there. So if a person build up a spacey model for NER detection, which is not detecting fully means, you know, that is not trained in that data set. So you should need to do that data annotation, collect the data set. After that, you have to do it. So that's what important. Next class, we will learn about semantic router. So that's another thing. And transformer architecture. So that's going to be very important. Please attend the class because that's going to be the future. Transformer architecture, right? So now we have removed the things and I'm going to load the clean data and I'm going to display over here what are the clean data. So here you can see one of the other reviews has mentioned that, right? One of the other reviewers has mentioned that the clean data looks like one reviewer has mentioned watching. That is removed, has removed, other removed, of removed, the removed. Right? Second, a wonderful little production. A removed, wonderful little production. Third line, I thought this was a wonderful way to spend. I removed, thought, wonderful way, spend time, not summer. So you get it what the stop word doing, right? Stop word removal mean, why we call it as stop word? When we read, one of the other reviewers has mentioned there's a pause we take. We don't say a wonderful, we say a wonderful little production. I thought this was, we take a pause at that point. So that's why he called it as stop words, right? So all the stop words removed. Now we got the clear data. Now, again, the same number of thing is there. The frequency is always the same. So now we are going to train the model. In the train model, I'm going to load the clean data set. I'm going to do the splitting, train split, XSplit, right, from the data set. And I'm going to do the logistic regression. So it's a kind of a easy way to do that, but this is not the optimum way to do that training using the Scikit. We have used this kind of training in the 4th week of Python, building up a neural network to solve a linear line problem, fitting a linear line. You remember the same library I'm using, the regression model fitting. So now the model is going to get trained. Then we are going to use the model to identify whether this is going to be done or something. So now it's done. So let's plot the training accuracy. My training accuracy is 0.88416. Not bad at all. So now I'm going to test the model, right? First, I'm going to say the movie was incredible. This movie is excellent. One comment. The plot was boring and predictable. Second comment. The movie was incredibly good with great storyline. Third comment. So let's see whether these comments are good or bad. So the prediction from our training model, this movie was excellent, positive. The plot was boring and predictable, negative. The movie was incredibly good with a great storyline, positive. You get it, right? So we are getting the right review. Let's go to the GPT or Gemini. I need few movie reviews. Good and bad. Okay, I'm going to get it. Paste it over here, the first comment, and go in here, second comment. Right? First two are good reviews because it mentioned as good reviews. And I'm going to go here and I'm going to say this is a good review. Okay. Then I go back here, copying one bad review over here. Right? And put it to this thing. Okay. So now I'm going to see how it's getting detected. So the positive, negative. I put the positive to thing and last one is a negative from the Gemini. It's detecting. So that means now we have trained a really good movie reviewing system. If you want a Pizza Hut reviewing system, same. So what we do, instead of this text, we filter out all the keywords from that thing and identify the text which is belongs to the keyword. How we do that? Tokenizing embeddings. Find that whole chunk, put it into this thing, play it. It's going to say what is positive, what is negative, right? So these are natural language processing tasks that we, in daily life, we use. How the Facebook blocks certain posts automatically. When you post a racist post, immediately the face will block that post. Right? How they do it? Same way. They analyze the sentiment. They train the model, good, bad, racism, like some other labels. I have done positive, negative only. So you can label it as positive, negative, racism, this black, blah, 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 blah things. Then when you post it, Facebook run, that post will go through the Facebook first model, that NLP model. Then it will be labeled as this or not. How the Facebook detects certain YouTube, eliminates certain video. So it's identify a video, upload it to their model, and the model has the ability to find out the video frames, colors. If you see blood color, you are showing something in blood color, that video will be blocked by the YouTube because it's identified that thing and do that, right? So that is kind of another video analysis way. When it's come to image analysis, we upload the image and we get it. So, okay, let me take another example. Go here, ChatGPT. Okay. Or scene. Okay, I'm going to download something. Okay, see, it's blocked. You can see it's blocked. Let me download something. I'm going to save the image, downloads, go over here. I'm going to upload that image, but I believe it won't say this thing because there is a face, because they have blocked if the face is there. Let me see. Okay. Okay. So this is the thing, image description. So when you post an image on Facebook, what they do is they take that image, send through this pipeline to get the description of the image. Then that image will be described over there. This description will be transferred into this thing, right? I'm going to place it as a second review. See whether it's a good review or bad review. The image description. Okay. So let me see. It's identified as positive, right? Second one as positive. So like that, the Facebook does the image. First is, does it go to image description, get the image description and put it into the review. And our review model is designed to detect the sentiment. It detects it's a positive or negative or racism or whatever, right? So that's how it happens. All right. So today, as a summary, we have learned how the words are processed in the computer, in AI, whether it's tokenized. After that, the token given embeddings. Based on the embeddings, we find these keywords. That's how the keyword search happened. So after that, we find out how the SPACY model NER works to identify certain key information. And we have trained our own SPACY model. Fourth one, we have used a model to train to define whether it's a positive comment or a negative comment, sentiment analysis, right? So these three are main things. There are a lot other stuff over there. So these basics three are enough for us to go for the next tutorial, right? So I hope you have enjoyed the session. Next week we will meet again and we will discuss the rest. Okay, that is going to be the dialogue with AI. We are going to go into the new transformer architecture management. So until then, see you. Bye.